Hello everyone, so welcome to this next talk. I will be your host, I'm Flo, and we'll speak about Unreal Gameplay Ability System. So just about me, I'm a gameplay programmer and a producer. In my industry life, I worked on the Wild Ship studio for the game Wild, but now I'm making a new studio and we work on our first title, which is Project Low. It's a top-down shooter with some hack and slash mechanics. And I will explain you why and how we used the G.A.S system for our game. So the game is still in prototype, so it will be mixed between developer art and more polished art. So first, what is the game ability system? It's an Unreal plugin. You may think to any RPG game like Diablo, and if you think to Diablo, you will think to all those numbers like the strength, the ability, the mana, the agility, but also the XP, the levels, and etc. And all those skills you can have to your player, like be able to cast a spell, or being able to cast a buff, and etc. The game ability system will help you to structure all of this code, and will do all the boilerplate code for you. So it's not only for RPG game, it can work with any kind of game. And actually it has been shipped with Fortnite. So it's a kind of robust plugin, and also it's network ready. If we want to explain the game ability system in a nutshell, in Unreal you have actor, it's kind of an entity for Unity. The first thing you have to do is to add a component for your actor, the U ability system component. And then you will be able to add attribute sets. Attribute set will gather all the numerical values, like we said, the health, the mana, the strength, or the XP, the level, etc. It's float only data. And usually you group it by theme, so you have one attribute for your character, one attribute set for your object, and so on. And then you have gameplay effect. The gameplay effect will act on those attribute sets. So if you want to make a damage, you will create a gameplay effect that will reduce life points on your attribute set. And finally, you have the gameplay ability. Gameplay ability are the skills or the reaction you can give to a player. And we will see all of that in more details. So first, the ability system component. When I started it, you have to make it in C++, and I think it's still the case, so there will be some C++ in the presentation and blueprint when it's possible. To implement the ability system component, it's quite simple. You just have to take your actor, so here it's the character, and you have to create a component like any other component. So it's the ability system component. You create it with create subdefault object. And just the little thing you have to do more is to implement the e-ability system interface, which give you some more power in the blueprint side. And then you create your attribute set. So as I said, attribute set are all the numerical value you have for your RPG game or for your game. So in our game, we have two kinds of attribute set. One for every character in the game, with mainly the health, the energy, which is the kind of mana we have, the speed, so we have a speed factor, so if you get a buff that slows down you, we change this value, and the level of the character. And we have also one for every equipment, so with the magazine size, so have how many bullets you have in your magazine, cooldown, so how many times you have to wait between two shoots, reload time, and also a level. Attribute set is a bit more boilerplate code, but it's still very easy to do. You have to put all your attributes with the F gameplay data attributes. So here it's just an example. I have just health on health max. You have some unwrap function. You have to do it. It's for network, but even if you are a solo game, you have to write those functions. And then you have some attribute accessors. There are some defines to give you some getters and setters for you. So you don't have to write your getters and setters, it's done for you. You just have to be careful because the F gameplay attribute data I said that attribute set are float only. And attribute gameplay data are two floats, the base value and the current value, but the base value is not the max value. For instance, if you get a hit, you will reduce your life points, and it will reduce both base value and current value. So you need to have health and health max if you need to have a max parameter for your numerical value. Current value is more like if you apply a buff that will temporarily reduce your number, the current value will be the temporary reduced values. Okay, so we have our character with the component ready, and we have our attributes. Now we want to add buff or give some hit effect. And for that, we have gameplay effect. Gameplay effects are mainly blueprints that are data only. So you don't have to write code, you just have some data to tweak. Main data is the duration. Kind of effect can be either instant, for instance a hit, or infinite, like a buff, or as a duration and be applied periodically. Then you can modify attributes. So you can add points or subtract points, multiply or divide the value you want to modify, or override it if you want to make some initialization. You can modify one attribute or more, or as many as you want. Gameplay effect can be stacked or not. So if you want to make to say that this buff can be applied only once, you can say that it can be applied more than once or more than 5 times. So you can stack buff or not if you want. And then finally, it can fail to apply. So you have two gameplay tags, and you can say that this gameplay effect can be applied. For instance, if you have a fire gameplay effect, it can't be applied if you are in water. So if you are in water, you will apply a gameplay tag water, and then all the gameplay tag fire can't apply. To apply a gameplay effect, it's quite simple. For instance, here we just have a trigger. We get the actor, we check if it has the gameplay ability system components, and if so, we just apply the gameplay effect. And with just that code, this one on the previous blueprint, we can make the hit effect. Okay, so you may know curve table with Unreal. So curve table are just table you can write by yourself, or you can import from any spreadsheet. And the column, we have levels, but we can have any numbers. And then we can have row that we can define ourselves. So here we have 9 levels and 2 rows, damage and durations. And we use it to manage the level effect of the gameplay. So here it's the same blueprint as previously, but instead we have more real-world example. So the blueprint has a duration, so it will do damage over the time and not only instant damage. We will modify the health attribute. Sorry, it has a duration. So the duration comes from the curve table. So if we apply this effect at level 5, the effect will last for 5 seconds. So it's not hard-coded data, it's coming from curve table. And also we change the magnitude. So what we change is the health, and we again apply data from the physical bleeding. So again, if at level 5, we will apply -16 of damage on health, set health attributes. And finally, we apply it every 1 second, so we can apply the period. It can come from curve table also, but here it's hard-coded. So it means that we will do damage over time. Every 1 second, we will reduce -16 of health for 5 seconds. Same as previously, the blueprint is quite simple. We just apply the gameplay effect, making sure that the actor has the correct component. But this time we use the level variables to control at which level we apply the gameplay effect. So the higher the level will be, the more damage and the more duration it will be. Same as previously, you see we can lose some damage, and it will last for some seconds. So here it's just 3 seconds. But you can see that with only few blueprints, I was able to make a system that is kind of the base of every RPG game. Okay, so I told you that we can subtract or add values to the game to our attributes, but we can also initialize or override the attributes. So here it's the gameplay effect we have in our system, and that will initialize all the characters in our games. So in our games, we don't have a code that says set the life of a character to 100. Instead, we have all our data in a spreadsheet, and we can say that at this level 5, this kind of character, so the main character, the player character, will have 100, and we can tweak everything in a spreadsheet. We import it with curve table in Unreal, and then at the beginning play, we'll apply this gameplay effect that will override all the attributes to initialize the life on every other character, every other attribute. So here we have the instant gameplay effect that will override both health and health max and set the attribute depending on the level, which is 50 at level 1. And excluding tag, as I said, if we can say that this gameplay effect can be applied or is removed if we have kind of tag applied to a character. So for instance, in our game you can enter some oil puddle, and if you enter this puddle, it will make you it will add a gameplay tag oil on you and then protect you against corrosive or acid damage. So you can see that we have a buff. Sorry, still on the previous slide. I think that the PowerPoint has stopped. Okay, so we have here the buff gameplay effect. On your left, you have the buff, so the protecting gameplay effect that will apply if you enter an oil puddle. If you enter such puddle, we apply gameplay effect with a duration that will grant you a gameplay tag, that say you have oil on you. And on the right, you have the damage gameplay effect that will do damage over the time and say that it can't be applied if you have the oil gameplay tag. Oh, sorry, I think the video is not working well. So normally the game does not look like this, as green as this. It's hard to see, but on the right you have the oil puddle, and you can see that when you enter the oil puddle, you don't take damage on the left ones. So here I take damage, but then when I go into oil, I can remove all the damage. And then when I have oil on me, it protects me against new damage. Okay, so now we have our character. We have the gameplay components. We have attributes on our characters, and we can make effects to give or to remove points, like to make it. But we also want to display sign and feedback to the player when such effect is applied. And for this, we have another blueprint type, which is the gameplay cues, and it's kind of magic because it will handle all the VFX or SFX parts for you. So gameplay cues, it's a blueprint with a function that is unexecuted, that you can override, that you should override. It can be instantiated actors or just execution code. And I said it's kind of magic because it will be triggered for you upon just upon specific tag. So on your gameplay effect, you say that it will trigger some tag that start with gameplay cue dot something, and then all the gameplay cues that match with tag will be spawned and triggered automatically for you. So on this example, on the left, you have the gameplay effect, and the gameplay effect as a section display And in this section display, we grant a tag, which is gameplay queue.damage.take damage. And all the gameplay queues that will match this tag will be triggered if this gameplay effect is applied. And on the right, you can see the gameplay queues with the matching tag gameplay queue.damage.take damage. On this gameplay queue, I can now override the onExecute function, and you can see that I just spawn another actor. The actor is the billboard that will show you the damage. So when you get a hit effect, it just pop out a damage billboard to show you how much damage you take or you made. Another example here, you can have as many as gameplay queue as you need. So this time we just have two gameplay queue. One is for the take damage to show you the damage, and another one is to show you that you take some acid damage. And again, on the onExecute section, I spawn a Niagara system. So when you take some acid damage, it just spawn VFX to show you that you take acid damage. So it's the same example as previously, but just here for the gameplay queues section, where when I take acid damage, I have both gameplay queues that are triggered for me. I did not have to make any code, just specify the gameplay tag, and then everything works for me. Just a quick note for you to understand the rest of the presentation. In our game, we have it's a kind of hack and slash. So we have this idea of we can customize our character or customize our weapon. So we have plugin that we can set on our character or on our weapon, and those plugins will buff the character or buff the weapon with some game effect or give abilities. And the player can spend the components, the currency or the money in the game, to increase the level of each plugin, and it will increase the level of the gameplay effect or the abilities. What I say that is because in this kind of game, in hack-and-slash game, we like to have icons when you get a buff. So either it's a good buff or a bad buff, we like to see icons in the game to reflect the buff you have on your character or on your weapons. I don't know why the presentation like this. I'm sorry for the image. It's not as green. But you can see that on this question, I have 2 buffs on my character and 1 buff for my minigun weapon. And to do this, to show you the icons, it's very simple. In the gameplay effect, you have a section just below the gameplay queues. You have a section where you can set a custom structure. So we just have a structure with a label on the icon. So when I apply a gameplay effect, I can say for this gameplay effect, we have this icon related to that. And that is very simple. We just pull all the gameplay effects on our character, get all active effects, and check if we use our structure. And if so, we just have to display the image in the UI. So it's very few lines of code to display this buff in our game. Very efficient to do. Okay, so now we have our character. We have some attributes. We can modify with gameplay effect, and we can show feedbacks when the effect is applied with gameplay cues. We now want to give abilities to our player or to any actor in the game. So the workflow of an ability is you first have to grant the ability to the character or to the actor to be able to use it. And then you have a function that is try to activate abilities that you can override to make your abilities. This function has a check cost first. This is useful because you may want to say that if you dash, your dash will use some energy points, and you must have enough energy points to afford the cost. And then you have activate ability, which is the code that you can override yourself to make your own ability. So you start first to commit, then you write your ability, you can cancel it at this point, and then you end the ability. Ah, cool, thank you. Okay, just an example of a SAMP gameplay ability, which is the heal. So on this example, we just commit the ability. It will spend the resources. So we said that we must have 30 of energy to use the heal. And then if the ability succeeds, we just apply a gameplay effect that will heal the player at a certain level, and the level depends on the level of the ability. And then we gracefully end the ability. To give an ability, it's quite simple. You just have one blueprint node or a few lines of code to do that. You just set the actor, so the gameplay actor component, which will be the target. You then set the ability and you define the level, because it's at the give ability that you define the level of the ability. So the problem is, if you want to make your ability evolve, if the player spend components to add a level to this ability, you have to first ungive it and then give it back with a higher level. And finally, you have an input ID you can set, because the system comes with an out-of-the-box system that say if you trigger a such key, the defined key, it will trigger the ability for you. You can use it or not if you want, but it's ready for you out of the box. And then the try to activate ability, you just activate as a gameplay effect. So you have to pass the ability system component, the ability to activate, and you have a return boolean to see if the ability succeeded or failed. You have to be careful, because if the ability failed because you don't have the resources to apply the ability, it will be positive, negative. I said a true negative, but the try activate ability can succeed, and it will be the bool will be positive, but in the ability itself you can fail, so it can be a false positive. Okay, and just to handle the cost of an ability, you handle it with a gameplay effect. So you stay in the same system, you just have to define a gameplay effect that say which attributes it will take resource from, and it has to be a negative numbers. So here we just take resources from the energy, and we have data from a curve table, and at level 1 we use 30 of energy to heal the character. Okay, quick note before continuing. We have ability task. So the ability I shown you is a quite simple and quite instant ability. It just heals the player. But usually, ability relies on more latent system, like the animations, and you want to wait the animation to finish before ending the ability. And for that, we have the ability task, which are latent nodes, like the delay node in Blueprint, that can tick and that are easy to implement in C++. And we will take an example of that with the interact. So in the game, you have an interact. You can interact with gameplay elements, and for that, we want the player to press the key long enough to successfully commit the ability. So to do that, we first initialize everything, like the UI and so on, and then we will trigger two latent task node. One is just a pure delay. So the delay is just a wait, and also another latent node, which is a wait input task. So we will wait for the player to release the input before this node is triggered. So the workflow is quite simple. If the delay trigger first, it means that the player has pressed the key long enough. And if the input release wait task trigger first, it means that the player release the key before the delay was last long enough. So if the delay lasts long enough, we just commit the ability and end it gracefully. Otherwise, we just cancel the ability and it will reset everything. And obviously, whatever the result is, we can clean up things. We have an on-end ability, and we can clean up things. So it's very handy to use it at the end. Okay, I think I'm a bit in advance. So the gameplay ability system, it's kind of hard to start with because we have some resources, but it's a bit complex. For a good start, I think that there are some YouTube tutorials to start with, and then the main resources are the Tranek GitHub. It's an unofficial documentation about the G.A.S system, but it's very useful. And also the G.A.S shooter, which is an example project. So you can get your inspiration from this project. For instance, the Interact come from the G.A.S shooter. And also you have the Lyra sample game. So I know it's kind of hard to dig into other projects to understand how things works, but it's very good. It's a very good example. And the last thing is the Discord. You have a very good community on Discord for Slack, and a lot of people are ready to answer to your question on game ability system. It's all for me. I just have a QR code if you want to get the presentation, in case it was not recorded. But thank you for your listening.
Just a question. You know where the gameplay ability system development is? Because like I went to the Unreal Fest thingy like 2 years ago, and they were saying, oh yeah, this will be included without any C++ in Unreal 5 and blah, 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 but nothing came. So you have any idea?
It's still, last time I checked it, it's still in development. I don't know how the word, but it was shipped with Fortnite, so we can think that it's kind of robust. And you still need to use some C++ code. You can't do everything in Blueprint. You still need to use some C++ code. It's still in beta, yeah. The word is still in beta.
Hello, thank you very much.
Sure, thank you.
So I'm not really used to the curve grids that you talked about. The curve, what was it called? The curve table, yeah. But does this mean that you can actually have the whole or most of the balancing of the game in a single, I don't know, CSV file that you can version? That's it. All your game there is balanced in a single CSV file somewhere.
Yeah, totally. So we have all our gameplay numerical values stored in Excel or any kind of spreadsheet, and we can tweak all those data in this spreadsheet, and then export in CSV and import in Unreal. So if we want to change like the damage here or the duration, here it's an example, but we will not change it in Unreal. We will actually change it in Excel and then re-import this work into Unreal.
Okay, so there is still some importing happening. It's not like live editing or anything like this.
I don't know. For me, I just do some import work.
Okay, all right.
But maybe there is a plugin that will do it for you.
Okay, thank you.
Thank you very much for the talk. It was interesting. Can you add other kind of data than float in curve tables?
No, I think curve table is just float data.
Okay, thank you.
But it's very handy because in your Excel you can have functions like you can use the logarithmic functions to pre-compute all your data and then export it into Unreal. And it's the same, just a last word, it's the same for attribute set. It's only float data attribute set. So you can't have integer value or array value in the attribute set. It's only float data.
Can you use curve tables in other contexts, in any context?
Yeah, curve table is not a gameplay ability. It does not come from G.A.S.
Yes.
It's a basic feature in Unreal.
Okay, so a proper asset then you can use anywhere.
Yeah.
Okay, thank you.
Totally. Cool. Thank you.